Okay, so the next measurement that we are going to find is volume. And remember that volume is how much space something takes up. It's also how loud something is, and if you think about it, the louder something is, the farther away you can hear it. So bigger volume, bigger space. Anyway, not the same thing, but it's kind of easy to remember it that way. So we're going to measure the volume of a sample of metal. This metal is a very irregular shape. I can't use length times width times height to find this volume. Not only that, it's hollow. So that would be very difficult to find the volume using other measurements. Not saying it couldn't be done, but it would be tricky. So we're going to use water displacement. Archimedes worked with water displacement. You might want to look him up. He's excellent. I think I'm going to tag some extra videos that you might want to look at in additional resources. In order to use water displacement, you can see that no two things can occupy the same space. So what we're going to do is we're going to place the objects into water. And you can see that the water rises. Well, how much the water rises will tell me how much space the object is taking up. So you're going to use graduated cylinder in order to get the best reading that you can. This graduated cylinder would be the most precise because it only goes up to 10 milliliters, which means that each mark is far apart, so I could get 1/10 of a milliliter each time, but they won't fit. So we had to go up a little bit. You want to make sure that there is enough water in the bottom of your beaker, the bottom of your graduated cylinder, so that you can see, so that you can drop the objects in there. They will completely fit under the water and you can see how much it rises. You don't want to fill it to the top, because if you did and your water rose up above your measurement line, you wouldn't be able to get an accurate measurement. You would have to guess. So let's go ahead and try that. Let me see if I can angle the computer without having to stop and clip to another video. I will take a picture of the measurement and upload it after we're done. Okay, that should be enough water to do this. If you will notice on your document, it only has one space for how many milliliters it is. So how do we know? You know by stop right now. If I drop those pieces of metal in there and it rises, is that how much volume it takes up? The answer is no. Because that would be the water plus the space that it took up. So how do we know how to do just the space it takes up? Think of the word plus. I have to subtract this volume. In order to subtract that volume, I'd better take the volume first. So I will show you the picture of the empty volume. If you were looking closely, you could see a slight green line in between the two spaces. That bottom of that green line is your meniscus, and that's where you would take that reading. So as we place our items in there, I'm going to turn this sideways because it is a glass graduated cylinder and I don't want them to slam onto the bottom, neither do I want it to splash everywhere. So we're going to slide them in there gently, one at a time. Okay, doesn't seem to be covered up, so let me see if I can. There we go. Move it over using my scapula. So you should be able to see even from there that it has moved some. So don't forget to show your work for subtracting the final volume from the starting volume, because that gives you the volume of just the water from the total volume. And that will tell you how much space the metal took up. And don't forget to show all of your work for converting from milliliters to liters. And remember which one's going to be bigger. Liters is larger, so your number should be smaller.